In today's tutorial, we'll be covering drip rate math. In the first problem, we're going to use a 3 kilogram patient. We're going to say that he is 8% dehydrated and he is vomiting 5 mils 3 times a day. The first problem we're going to do is maintenance. Maintenance is 40 to 60 mils per kilogram for a 24-hour period. We're going to stick with 50 just to be right in the middle. So 3 times 50 equals 150. Next is dehydration or hydration deficit. We're going to use the 3 kilograms again. Then we're going to times it by the percent dehydrated, and I'll always provide that for you in these problems. And then we're going to times this by 10, and this will equal 240. Then lastly is losses. And so we said he's vomiting 5 mils 3 times a day, which equals 15. Tally up 150 plus 240 plus 15 equals 405 mils that we would need to replace in a 24-hour period. So we need to take this 24-hour period, bring it down to per second, what we're going to be delivering, and also using a either macro or micro drip set. So the first number we're going to divide this by is 1440. 1440 represents dividing it by 24 and then by 60. So we're getting down per minute. So 405 divided by 1440 is going to equal 0.281. Now we need to go down to seconds. We're going to divide this again by 60, and this is going to equal 0.0046. Now we need to multiply by the type of drip set. And in this case, he's a 3 kilogram patient, so he needs a micro drip set, which is going to be 60 drip per mil set. So then we go back and we actually just multiply this by 60, which will bring it back up to the 0.28 drips per second. We can't work with this number. We need to get a whole drip per second. So what I'm going to do, what I see is going to be the easiest, is just change this number to 0.25, only losing about 0.03, and then we'll times this by 4, and then we'll get 1 drop per 4 seconds. Whatever you multiply by right here, that's what your time is going to represent as. Let's do another one. New whiteboard. All right, this time we're going to start off with a 20-kilogram patient. He is going to be 10% dehydrated with no vomiting or diarrhea. So first number is going to be maintenance. We're going to take kilograms, which is 20, and times it by 50. And that is going to equal 1,000. Then our dehydration rate is going to be kilograms times the percent dehydrated times 10. And that's going to equal 2,000. And then tally those up. And so he would need 3,000 mils or 3 liters in a 24-hour period. Now we need to work it down to get drips per second. So let's divide by 1440. And that is going to equal 2.083. Let's just keep those numbers in our calculator. And that is per minute. Let's divide this to get per second, and that will equal 0.034. And then finally, we have to pick drip set. And so because he's a 20-kilogram patient, he's going to get a macro drip. Macro drips typically come in 10, 15, and 20. For this problem, we are going to use the 20 drip set. So times by 20 and that will give you 0.69, and this is drips per second. Now this number is not going to work again. We still need to round it to get whole drips per over time period. So what I see is 0.7, pretty easy to round to. Then we'll just times this by 10 and get 7 drips per 10 seconds. You could also go to 0.66 and then probably round it by 4 or 5 to get close to that whole number, and that would work out just fine. If you have any more questions, please don't hesitate to reach out to tstone@pmi.edu. Thanks.